All right, welcome back for Op 2. This should be the second part of this. In the previous video, we went and machined Op 1, so our finished part ends up looking something like this. And so we just are gonna flip it over and work on the other side now. So we're gonna do something a little bit different in this video in that we're going to be working with a manufacturing model in Fusion 360 that has a fixture, and it will allow us to do fixture aware collision avoidance. Okay, so the more that we tell Fusion 360 about our setup, like what machine, what fixture, what tools we have, the better it's going to have an idea of what it can and can't do. So to help us a little bit, we're going to create a manufacturing model. And this is pretty helpful because what it allows us to do is make changes to this design for manufacturability without actually changing the design intention in the Fusion 360 design. Okay, so I had one in here previously, but when I added in this new one, it's manufacturing model 2. So I'm going to edit this. When I right click and click edit, it brings me into an environment that's similar to design, okay? But this is kind of a special instance because I can now start adding in components that I didn't have previously here. So the thing that I want to put in here specifically is one of the machine devices. So in Fusion 360, it has built-in fixturing, which is kind of nice. When we go to, I think cam samples, yeah, cam samples and then work holding, it has a bunch of different types of work holding. You can get, Saunders machine vice or machine tables, fixture tables. You can get fifth axis stuff, OS stuff. That's totally fine. In our case, we want to pull in a generic vice, and normally we'd try to copy it in here, but you do have to copy it to your personal library first. So when I right click and click copy, it wants me to put it somewhere. I've already copied this a couple different times to this IMSE curriculum folder. You can put it wherever, admin project, default project. If you have a Jacob Hamilton assets folder, you could throw it in there too, but we'll just copy it into a folder. And then when I'm in Fusion 360 here, I'm going to go to wherever I stored it, generic device, 4/13/26, 1:26 p.m. I'm just going to click and drag that into here. Oh, just kidding. Doesn't want me to do that. So I am going to switch. I'm going to finish editing here. I'm going to switch into the design workspace, and I'm just going to insert this component. Cancel. Doesn't like me inserting a component either. Let's see if we can do that again. Edit, insert component. Can I not insert a assembly generic vice? Huh. Interesting. The more you know. Assemble, insert component. Wow. I don't know how I did this earlier. So let's go back to the design workspace then, and we'll add it in there. Add in our generic vice. Yeah, let's create an assembly, or convert to an assembly. So I'm just going to add my vice in here. It doesn't really matter where I put it for now. We're just going to click OK. Now I'm going to switch back to manufacture. I'm going to go to my manufacturing model, edit. Perfect. All right. So this is kind of neat now. because I have this vise and I can make changes to it, and they will be saved just in this manufacturing model. We don't have to worry about it changing our design. So in this case, I'm going to take this generic vise and I want to move this front jaw just a little bit in order to open it up to get our model to sit in there. So what I'm going to do is I'm going to see if I can create a joint, or at least move this component. Yep, 1 inch. Perfect. So if you select the move command, you can pick the component and you can pick that front jaw and just move it back by 1 inch, which is pretty handy. And now we can locate our part within this vise. So I do want, let's right click this. Let's just make it a rigid group for now. And we're going to capture position. Yep, we'll just select all of those components. Perfect. So now this is locked in place. This whole assembly will always be in the same, it's always going to be the same relative to one another. Okay. So next thing I'm going to do is I want to create a joint. I'm going to go back to our clamp geometry, go back to our manufacturing model, and I'm going to create a joint. So I'm going to go to Assemble, Joint, and I want to select this joint origin here. That's on the top of the vise jaw. And I want to pick this surface on our part. I'm going to match it up with the bottom point here. And so it moves the fixed jaw just to show you where it's going to be. Notice that the part is currently hanging out of the vise. We want it to be within the vise a little bit. So I'm going to move it up. Let's move it to 125. Okay, so it's 1/8 of an inch within the vise. That's fine. And it matches the model orientation that we're going to be machining in. So when I click OK, it should move the vise to match the part. And now we've got a vise that we can use as a fixture here. Okay. So when I finish edit, it pulls in that geometry to Model 2. I'm going to activate my, we haven't made an Op2 setup. So I'm going to create an Op2 setup. So I'm going to go to Setup. I will select Milling. Model orientation is fine, right? We got to mill this top surface. Stock box point. This is kind of weird. It's picking stock that includes our vise. Well, we've created manufacturing model 2, but we haven't specified which component within that model is the one we want to machine. So I'm going to just select our little bracket feature here, and notice that it kind of selects down to that part. Our fixture here, I'm going to go into our manufacturing model and select generic vise. And I do want to drop these clearances because I do know this is going to cause issues later if we don't. We'll set the radial and axial clearances to 50 thousandths of an inch. And that looks good. Now, I mentioned previously that we need to be able to locate this part once we flip it over. And had we done this operation first, we didn't have a good surface to locate off of. Well, we also don't have a very easy surface to locate. We do have this surface, which is sitting beneath here. So what this means is we're going to need to add in a vise stop within this channel here, and we'll butt up this surface against that vise stop. Now, in Fusion 360, to be able to set that as a as our datum point, we need to make a couple modifications here. And the good news is we can do that within our manufacturing model. So let me show you the issue here. When I go to Setup and I want to select my origin, I can select individual points on our model and use that as our origin. Well, I thought I was being clever earlier, and I added in chamfers everywhere. Well, the problem with that is when I add that chamfer, I no longer have that bottom corner point on this face that I can locate, which is kind of annoying, right? The only way for me to select that were to be if I created a sketch on here on this surface, I could then click on that sketch point, which is what we're going to have to do. So I'm going to get out of here. I'm going to go into our manufacturing model and edit. So when I edit this, you can create a sketch. And I'm going to create a sketch on that vice jaw. I'll rotate my part. I can project. I can go to create, project, include, project. And we're going to click that left undercut surface, and I'm also going to select the bottom of the part. Okay. So I have those two surfaces projected in to the vice jaw drawing. I'm going to hide our generic vice over here. And I can draw lines between them. I'm going to create what looks to be a right angle, albeit I still need to add in perpendicularity between the two. Perfect. And just for continuity, let's add a point in there. Point. Finish sketch. So what this says is we now have a point on the fixed jaw of our vice that lines up with this face and lines up with this face. The intersection of those three planes is that point. So I'm going to finish editing. Perfect. And now we can see we've got that sketch in our manufacturing model, which is pretty cool. So I'll edit, and instead of selecting that corner point on the body, I will select that corner point on the sketch. We've now selected a point in space that does not exist, right? There's no way that we could ever probe that point, but we can probe all three surfaces on our fixture to be able to get it defined as our datum within the machine. So we'll select that. We'll have to use a 1, 2, 3 block to get that located, but that's fine. You could try to use this as a, you could put a pin in here and then locate off of that pin, especially if you had a probe. You could probe that. We're not going to be using probes. We're going to be using edge finders because I'm a mean instructor. And because of that, we'll put a vice stop in here, put a 1, 2, 3 block, and then locate using the 1, 2, 3 block. So, got the part, we could start doing all of our operations. So, going to run some adaptive clearing. We will run with our 1/2" flat end mill. Go to geometry. I'm going to go back over, hide our sketches here. Notice that in our adaptive, when we look at our surface groups, it's now got a fixture in here. And so the values that we had in our setup for the radial and axial clearance automatically get loaded in here, which is pretty neat. So we don't have to worry about much. We do want to make sure that the bottom of our tool isn't going to collide with our part. But with the fixture in there, Fusion kind of already takes care of that for us here. So I'm going to change the bottom height to be a selection, and I'm going to pick that surface. It will offset it by 20 thousandths. Let's change that to 0. Perfect. So it'll go directly down to that face. When I go to my passes tab, let's change our stock to leave to 10 thousandths. And I'll turn smoothing on. And then one change I do want to make is the optimal load, or our step over, effectively. So one of the reasons is this is a cantilever. right? When we start applying force on the end of this cantilever, it's like we've started using like a can opener or a pop can. We've added in this long lever and there's very little material supporting it, right? This is going to start deflecting it when we start adding our upward cutting force. And so the larger our step over is, the larger that force is, and that's going to start yanking our part out of the vise. Or it's going to start deflecting this end, and we're going to see some chatter. Not good. So to reduce our cutting forces, I'm going to drop our step over down to 25 thousandths of an inch. Now we're working with carbide. Carbide's pretty sharp. If we had a dull carbide, I'd be more concerned about that step over, but for this size tool, 5% of the cutting diameter is going to be just fine. So, click OK. It's going to generate our toolpath. Looks good. All good. So, toolpath looks good. I'm going to add in another adaptive operation here. I'm going to right click and actually click duplicate. We'll keep everything, it'll keep all of the changes we just made, but I'm going to add in a couple changes. When we go to machine this surface, it'd be really nice when we go to finish machine if we don't have really large cusps that we have to machine off. So I'm going to do what I like to call a semi-roughing operation. This is just going to get this down to a much closer size. So what I'm going to do is I'm going to select this surface. We'll keep the tool outside boundary. Let's keep tool center on boundary. Yep, perfect. And then for our passes, for our fine step down, rather than doing 100 thou, let's do 25 thousandths or 0.025. I'm also going to drop our stock to leave to about 5 thousandths. And when I click OK, this is going to take considerably smaller passes, and it's going to take a little bit longer, but it should reduce the steps that we have to machine by quite a bit. Now, it isn't going down all the way, which is kind of weird. So I'm going to change a couple of our parameters here. I also want to, let's select that surface as well. Still not going down all the way. It's kind of annoying. And yeah, it's leaving that face. Huh. All right, well, we'll keep making some edits here. Let's tool outside boundary. Okay. That looks good. That looks a lot better. Much better. Okay. So, with that tool outside the boundary, it will let us do that, which is kind of nice. I should have left it the way it was. So, we can see we got even step downs here. These are going to be much more amenable to our ball end mill. I'm not too worried about this little stuff down here. That step we're not really going to be able to hit well, but that's okay. I'm not too worried about that right now. Okay, so the outside of our part is roughed. We can start looking at finishing. So I'm going to focus on the silhouette of the part now. We'll run another 2D contour with the silhouette. We'll run our outside loops. Bottom height, we don't want to go all the way down into the vise here, but by default it does do that. So now that we have our fixture in there, I wonder, no, it violates the fixture. So we're going to go back in here, and then for our bottom height, I will select this surface. So it will run a silhouette, and it will only go down to that surface, which is nice. So it finishes the outside of our part. The outside of our part should have already been finished in op1. So when I go to edit, let's edit our setup. That's what the issue is. I have our stock mode set for relative. We want to go from the preceding setup. And then I also want to continue rest machining. Yes, I'm going to ignore. All right, when we do that, it is going to make us regenerate our operations. That's fine. Yep. Toolpath still looks good. That toolpath still looks good. This toolpath still looks good. Okay. All right, that's much better. Okay, so we've got that finished up. Let's run a quick flat operation on the top of the part. Let's run aluminum finish. And let's select just this top surface. No, I just want to do this contour. I don't want to do the face contour. I just want to do the entire surface here. Yeah, and step over here. Let's set tool diameter times 0.75. We'll throw on smoothing. Click OK. Take a second to generate. Looks good. What I don't like is it went down into that pocket, and it did it before we had machined anything, which is kind of a problem. So I'm going to edit, and we're going to go back to geometry, and I wanted to avoid that surface. So I'll go down to our surface groups, I will add an avoid surface, and then click on that face. Oop. Okay. So now it will avoid that face when it generates the toolpath. Looks good. Wow, it really is not going all the way to the edge. So, well, we're just going to remove that. We're going to remove our selection. We're just going to tell it none. I want you to get every face, and then for our avoid surfaces, let's also just avoid those two faces. Okay. Okay, that should be at least a little bit better. Yeah. All right, now we're fully machining that face. Perfect. All right, now we can start working with our smaller diameter tooling to get into this little area here and also inside the pocket. So I'll add a 3D adaptive clearing, 1/4 inch flat end mill, aluminum. For geometry, let's select a machining boundary. Select that and that. Looks good. Tool outside is fine. Model bottom to model top. This is, because we're working with a smaller tool, let's leave 5 thousandths on the axial, and yeah, that step down is fine. Optimal load is fine. I'll click OK. We'll let it generate. We'll see what it does, and then we might need to make a change or two. I think I'm okay with that. I think I'm okay with that. It's not going to bother me too much. That looks good. Let's do it again. We'll duplicate, but this time for our geometry, let's select this pocket. Now remember, we've already bored out this pocket from the other side, so we don't need to do that again. Instead, we want it to go into the pocket, and we want to only go down to that surface. So I'll set my bottom height as that surface. Radial, everything is fine. It will ramp down into the material because it's solid, so it does need to ramp. I will throw a 1 degree helix on there. By default, it goes to 2 degrees, but I found that 1 degree just makes me feel a lot better in the machining operation here. So 1 degree to get that surface all cleaned up. And it will leave a little bit of stock on the walls, which we can clean up with a 2D contour, 1/2 inch flat, aluminum finish, contour selection, boom, heights, passes, just for fun. Let's add a couple roughing passes, and we'll turn on smoothing. There we go. So the tool will come down, it'll plunge, go down to that surface, and then clear out that pocket. So that looks good. We just have this surfacing to do, and then also the deburring operation. So for this surface, I would lean to a parallel operation. Let's choose our 3/8 inch ball end mill. For our geometry, I am going to down select to this surface, and it will by default avoid our fixture, which is handy. I do want to throw contact point boundary on, and keeping the tool at the center should be fine. And when I click OK, looks pretty darn good. It might be getting a little bit too close to our fixture. Like when we translate to the real machine, that fixture may be off by a little bit. So to make our life just a little bit easier, I'm going to set a bottom height. We're just going to go down to, let's just go down to that face. That'll just make me feel a little bit better when we get to the real machine, that we don't plunge into the vise. And that's fine. We can sand that off or file it off. And I can't believe you guys didn't tell me I missed the flat operation, the contour on this surface here. So got to go back and do that real quick. Let's go to our flat. I'll use my 1/4 inch flat end mill with aluminum feeds and speeds. Finish. Machining boundary, I want to select that face and that face. Heights, model bottom. And we'll throw smoothing on. Step over of 26 thousandths, that's fine. So it should generate our flat operation here. To clean that up, it's not getting all the way outside of there, which I'm not a huge fan of. So let's set our tool outside boundary. And that should be good. Okay. It's a little bit longer of an operation than I would have liked, but that's okay. All good. So I'm actually going to click and drag that. I'm going to move that up. So it's grouped with the Tool 5 tools, minimize our tool changes. Run parallel, looks good. Okay, now the last thing we have to do is deburr, which is pretty nice. So I'll run 3D deburr, run our 3/8 inch ball again. We'll set our geometry. Don't really need to do much here. I will change our bottom height to selection. Pick that bottom face. Passes. That's fine. Let's see what that does. It should automatically avoid our vise since we added our fixture in there, but And it does. It's pretty handy. It is trying to do like a couple little ghost cuts here, where it's trying to cut that bottom chamfer even though it doesn't need to. I am not going to worry about that too much. Yeah, and it's doing the inside and everything. So last thing to do is let's simulate this. So we'll simulate with the comparison. Taking nice small cuts, which is good. We're not optimizing for speed right now, so I'm not too worried about, some of these operations being a little bit longer. Look at that. Beautiful. Now, keep in mind, we are missing this material here. If we were really diligent, we could scoot the part over to the edge of the vise and leave this surface hanging out. And then we could get it with our parallel operation. But I'm not too worried about that right now. We're just gonna work with it the way it is. So, yeah, so this is op 2, that's how we do it. The next steps would be posting and then running it on the machine. So go ahead and get started, and yeah, when we get back to class next week, we should be able to start machining.